All right, now let's try one more time. Exactly the same what we just did in the last video. Okay, so draw out all possible stereoisomers. How many are there though? Possible stereoisomers. Let's look at this molecule. Okay, how many chiral centers are there? 2, so 2 to the second, 4 maximum stereoisomers. Right? So you can do up down, you can do down up, you can do up up, you can do down down. Okay, now let's check the stereo relationship between 1 and 2, 3 and 4, 1, 3, 2, 4. We can do that. All right. So first of all, 1 and 2, are they chiral? Okay, are they chiral? Are they a chiral compound? So start with chiral center. Do they have chiral center? Yes, 2 each. Right, 2 each. So yes. Do they have plane of symmetry? No, they don't have plane of symmetry. If you put a line, an imaginary plane or line down here, left and right doesn't look the same. This OH point up, this OH point down. This OH point line right here, OH point down, OH point up. Okay. So they both are chiral, and they are mirror images. Are they? They are up down down up. So they are enantiomers. All right. Look at the stereo relationship between 3 and 4. First of all, are they chiral? Okay. Do they have chiral centers? Yes. 1 and 2. 2 of them, 2 each. Okay. Do they have plane of symmetry? They do. They do have plane of symmetry. Look at that. Draw the line right here or plane right here on the left and the right look exactly the same. Right? So these guys are not chiral. They are achiral. And by the way, take a look at what happened. Compound 3 and 4. If I flip compound 4, 180 degrees, look just like compound 3. This guy, 3 and 4 are actually the same compound. They are not isomer. They are exactly the same, right? They are identical. What I want to say again, so this I showed you before, but just want to reinforce that. A plane of symmetry make a pair of enantiomer identical. They're supposed to be enantiomer, supposed to be chiral, but plane of symmetry would make molecules symmetrical, so they don't have a symmetrical carbon anymore. The chiral center doesn't do the job anymore. Okay, so basically they are achiral, and apparently 3 and 4 are actually the same compound. All right, so in this case we call this compound a Meso compound. Just kidding, that's a Meso compound. Anyone, if you like Japanese, the miso soup, that's just my sense of humor. Okay, so we call it Meso compound, not meso, not meso. It's me and so, like you and me, and so Meso compound. All right, so this guy is a Meso compound, and yep. So Meso compounds possessing 2 or more chiral centers they have plane of symmetry, and plane of symmetry destroy chirality. All right, which means a pair of enantiomers are the same compound. They are identical. All right. So when you determine the stereo relationship, so you got to watch out which maybe some of those are actually the same compound. Look for the plane of symmetry. Okay. All right. That's the last stereoisomer. It's not really an isomer. This one just the same compound. So anyway, so they are in the same category here. We have mirror image kind, not mirror image kind, right? And this guy are actually identical. We call Meso compound because it got plane of symmetry. This guy are achiral. Okay. All right. All right. Let's practice one together. All right. Draw all possible stereoisomers, and and each possible stereoisomer should be drawn only once. So you have to be aware which one repeat or become identical. All right. All right. So first I'll start with how many possible stereoisomers are there? There are 2 chiral centers, so 4 total. 2 to the second, so 4 total. Okay. And anyone here, what happened? These are looks like enantiomers. Nope, there's not enantiomer. This got plane of symmetry. Yeah. So basically, this guy are actually the same compound. Now this guy are identical, right? So if I flip the first compound like that, look just like the second. Up, up, you're gonna go down, down. If you flip it 180 degrees, they are the same compound. It's a Meso compound. These 2, oh, something wrong with the OH there. Something wrong. There's supposed to be an OH there. These 2 are enantiomer. Up, down, down, and up. Okay. So they are isomer for this guy. There are only 3. So this 1, 2. No. This is 1, 2, and 3. So there are only 3 stereoisomer for this compound. All right. So we have these are the same, identical. These 2 are enantiomers. These guys are diastereomers. Okay, this also diastereomers. This also okay, the same thing. Never mind. Okay. All right, class activity number 3. They have an answer right there. Got a hint down there. All right. Okay. Let's go to the next video.